I am Zaiba, Assistant Professor in Electronics and Communication Department. Today my topic is clock D flip-flop. So before starting this topic, firstly we have to clear what is flip-flop. Flip-flop is a synchronous sequential circuit. The word synchronous means we will use the clock pulse to activate our flip-flop. So that is the block diagram of simple D flip-flop in which single input D will be applied. We will get the two output, that is the Qn plus 1 or Qn plus 1 bar, that represent the next stage of the flip-flop. Second, this is the basic block diagram or basic construction of the D flip-flop, means D flip-flop will be fabricated with the help of the SR flip-flop. If in case of S input we will use the D, and for the R input we will use the complement of the D, then we will convert the SR flip-flop into the D flip-flop. So we have to discuss the working of the D flip-flop. This is the working diagram for the D flip-flop. It is the case 1. For case 1 is that we have the two single input, that is D. So for the single input we have the two options. The value of the D will be 0 or 1. For this condition 0 or 1, we have to calculate the value of the next output, that is the Qn plus 1. To explain the output of the D flip-flop, we will make the basic of the NAND gate. This is the basic truth table of the NAND gate, which is saying if both the input are 0, then output will be 1. If 0-1 condition, then output will be also 1. 1-0 condition, it will be also 1. So it is indicating if any one of the input is 0, then output will become 1. That means if for any gate, NAND gate, one input will be 0, then output will become 1. Doesn't matter what will be the value of the other input. So we will make basic of this, then explanation of this. Let first condition D is 0. If D is 0, then complement of this one will be 1. Now see, clock pulse will be always 1 to activate the flip-flop. So first case is that if D is 0 and clock pulse is 1, then the AND gate, one gate output is 0 into 1, then output will be 0. For 1 into 1, then output will be 1. So for the gate number 3, one input is 0, which is NAND gate. So I already told you that if one input is 0, then output will become 1. And the Qn plus 1 bar, if Qn plus 1 is equal to 1, then Qn plus 1 bar will be opposite of this one, that is equal to the 0. So under this condition, output will become 1. Next, if D equal to 1, if input we will convert it into the 1, then complement of this one will become 0. Clock will be 1 in this case also. So 1 into 1, S will be equal to the 1 and R will be equal to the 0. Now again, if gate number 4, one input is 0, then output Qn plus 1 bar equal to the 1 and complement of this will equal to 0. That will implies that if D equal to 1, then we will get Qn plus 1 equal to 0. So that is the basic truth table of the D flip-flop. Now if we have to draw the characteristics table for this one, then characteristics table will be drawn between the present state or next stage. Present state will be represented by the Qn, input will be represented by the D, next state will be represented by the Qn plus 1. Now if we have the two variable Q and D, then the combination will be become 0 0, 0 1, 1 0 and the 1 1. Now if input is 0, then output will become Qn plus 1 is 1. So we can write it over here is 1. If input is 1, then output is 0. So we can write it here 0. Again, if input is 0, then output is 1. One case means 0. That is the characteristics table for characteristics table of clock D flip-flop. If we have to draw the excitation table for this, excitation table will be drawn between the output and input variable, means in this case we have to find out the value of the input. Next, that is the present state, it is Qn, next state is Qn plus 1, input is D. So the basic combination will become 0 0, 0 1, 1 0 and 1 1. Now excitation table will be drawn with the help of the characteristics table. In excitation table value is given 0 0. If Qn 0, Qn plus 1 0. If Qn 0, Qn plus 1 is 0, then what is the value of the input? D is 1. So we can write it over here is 1. Next case, if Qn 0, Qn plus 1, then Qn 0 and Qn plus 1, then D equal to 0. So we can write it over here the value 0. Again 1 0 situation is showing if Qn is 0 and the Qn plus 1 is Qn is 0, right, and Qn plus 1, Qn is 1 and Qn plus 1 is 0, then this one situation, Qn is 1 and Qn plus 1 is 0, then D value is equal to the 1, and the next case we will get the value is 0. That is the excitation table for the D flip flop.